Hey guys, and welcome back to this class, Data Science, Deep Learning in Python Part 2. In this lecture, we're going to look at Theano Basics. We're going to cover enough parts of Theano so that you can comfortably build your own neural network. And then in the next lecture, we're actually going to build a neural network in Theano and test it on our data set. So if you want to get the code I'm using in this lecture, it's github.com/lazyprogrammer/machine learning examples, and go to the ANN class 2 folder and look at the file theano1.py. So I'm going to run it bit by bit in IPython so you can see what's going on. So whereas going from regular Python to NumPy or Pandas isn't that much of a mental leap, going from NumPy to Theano is. There are a lot of new concepts and things don't happen like you would expect them to in regular Python. I'm not going to show you how to install Theano since that's pretty straightforward. Just go to their website and follow the instructions. I haven't heard of anyone having issues with it before. Now that you've done that, the first thing we'll talk about are Theano variables. So we use Theano tensor so much that we just call it capital T usually. So we can create a scalar like this, t.scalar, and you pass in the name as the first parameter. So we can do the same for a vector and a matrix. Now we also have tensors in Theano, and those are for dimensionality 3 and up. You might see these if you work with an image that hasn't been flattened like the ones we're using. So we have vectors that are 784 in length but need to be reshaped to 28 by 28 to view the image. So if you wanted to store the images as squares and you had n images, then that would be n by 28 by 28, which is a 3-dimensional tensor. If you had 3 color channels, for example, red, green, and blue channels, then you would have an n by 3 by 28 by 28 tensor, which is a 4-dimensional tensor. We're not working with tensors in this class, so that's all I'm going to say about them. So notice also that the variables I've created so far don't have actual values. All the variables we've created are just symbols, so we can even do algebra on them. As an example, let's do a dot product between A and V. But we haven't actually done any multiplication, which would be impossible since A and V don't have any values yet. So how do we set values to A and V and find the result W? This is where Theano functions come into play. So let's import the top-level Theano module. We can use this to create a Theano function. Each function creation specifies the inputs and outputs. And now let's import NumPy so we can create real arrays and call the function. So this is how we call the function. And we get the expected result. So that's nothing very exciting so far. One of the biggest advantages of Theano is that it links all these variables up into a graph, and we can use that structure to calculate gradients for you using the chain rule, which we discussed in the first course. In Theano, regular variables are not updatable, And to make an updatable variable, we need to create what is called a shared variable. So let's do that now. So the first parameter here is the initial value, and the second parameter is its name. Let's also create a simple cost function that we can solve ourselves and we know has a global minimum. And then let's tell Theano how we want to update x by giving it an update expression. So what's nice about Theano is that it calculates gradients automatically. The grad function takes in two parameters. The first is the function you want to take the gradient of, and the second is the variable you want the gradient with respect to. You can pass in multiple variables as a list into the second parameter. So now let's create the Theano train function. It's like the previous function we created, except we're going to add a new argument, which is updates. The updates argument takes in a list of tuples, and each tuple has two things in it. The first thing is the shared variable to update, and the second thing is the update expression to use. So this has no inputs. You'll see why later. Okay, so we've created a function to train, but we haven't actually called it yet. Now notice that x is not an input, it's the thing that we update. In later examples, the inputs will be the data and labels. So the inputs param takes in data and labels, and the updates param takes in your model parameters with their updates. Now we have to write our own loop to call the training function. Okay, so it converges pretty quickly. Notice that we've converged to the expected cost, and we can print the optimal value of x using the getValue function, and this is also what we expect.